Here's the answer key for the antiderivative study guide. Question number 1, if the velocity of a particle moving along the x-axis is v of t equals 2t minus 4, and we have the initial condition that when t is 0, the position is 4, what is the position at any time x of t? Alright, so we want to take our antiderivative and then figure out what c is. So the antiderivative of 2t minus 4 will be t squared minus 4t plus c. So that is our x of t. That's our position function because position is the antiderivative of velocity. Now we know that when t is 0, the position is 4. So 4 equals 0 minus 4 times 0 plus c. So c is equal to 4. So therefore, we are looking at x of t being equal to t squared minus 4t plus 4, which is c. Problem number 2, cosine of 3x. We want that antiderivative. So this is a situation with u substitution. Right? So u is going to be equal to 3x. And the derivative of 3x is 3. So keep our differential in there. So we have du equals 3 dx. We don't have the 3, so we need to put it in there. And we counterbalance that with the 1/3 on the outside. So this is equal to 1/3 times the antiderivative of cosine, and then 3x is replaced by u, so we have cosine u, and the 3 and the dx are replaced by du. And now we have to do our antiderivative. This is where you got to be careful. The antiderivative of cosine is sine, not the opposite of sine. So we have 1/3 sine u plus c, and we replace u with x, so we have 1/3 the sine of 3x plus c. So we're looking at C as our answer, once again, not B. Got to be careful with your negative signs as you're doing your antiderivatives. For number 3, it looks like it's another u substitution problem. If we were to make u equal to x cubed plus 1, well then du would be 3x squared dx. We have the dx, but we don't have the 3x squared. If we just needed a 3, we could put a 3 in the integrand and a 1/3 out front, like we did with the previous problem. But because there's an x squared, we can't just add in an x squared because we need it. So we have to go to an alternate route to answer this question. Okay, this one cannot be done through u substitution. How do we go about this without u substitution? Well, it's similar to one of the problems that we did in class. All right, we have x cubed plus 1 being squared, which means we have x cubed plus 1 times x cubed plus 1. Right? We have a product that we can, in fact, FOIL. And that's what we're looking to do here. If we do FOIL this antiderivative, x cubed times itself is x to the 6th. Then x cubed times 1, and 1 times x cubed means that we have 2x cubed. And then last, 1 plus 1 is 1. So we have to rewrite our antiderivative as so. We need to expand out that binomial. Now we can take our antiderivative. X to the 6th becomes x to the 7th over 7. Well, that eliminates everything but a and b for starters. And then 2x cubed becomes 2x to the 4th over 4, which we see the 2 and the 4. We can simplify that to 1/2, and that verifies that our answer is going to be b. But we could keep on going. The 1 goes to x, and then we need our arbitrary constant at the end. All right, and finally with number 4 on the front page, we have the antiderivative of sine 2x plus cosine 2x dx. And because we are adding, we can actually split this up into 2 antiderivatives. You can do this all in one. I'm going to split it into 2 just quickly, just to have everything double checked. Now in both of these situations, u is going to be equal to 2x, and du is equal to 2 dx. And we don't have the 2 in either of the situations, so we're going to need a 2 and a 1/2, and a 2 and a 1/2, like so. All right, now this is very much like problem number 2. It's just twice the fun. All right, so we're going to have 1/2, and then sine will antiderive to negative cosine, and we'll keep the 2x. And then we have a plus c there, but we're also going to have a plus c from here, so we just have 1 plus c at the end. And we see plus 1/2, and then cosine's antiderivative is sine, so 2x, and then our plus c. So we're looking to see which one does this match up with, And it seems like it matches up perfectly with the choice right underneath it, where the cosine is negative and the sine is positive.